Okay, so today we will see K-means clustering algorithm, and we will see one of the numerical problem associated with this. Okay, so basically, clustering algorithms, as we have already seen, they are type of unsupervised learning algorithm. Okay, what do you mean by unsupervised learning algorithms? So they have the data, okay, but there is no you say output labels or output values associated with this data. Okay, so there is no output labels or no values associated with the data. So you have just plain data. So for example, let us say consider there are two features, let's say x1 and x2. So you will have some numerical value with this x1 and x2, but there is no as such y available with this. Okay, so you cannot say any class, any value associated with this. Okay, so this is unsupervised learning. You have only the data, no output value or no output labels are associated. So what we need to do, we need to understand the data. Okay, so we need to understand what that particular data represent, and what we have to do is we have to get information out of it. Okay, so if you are given with the data, then you have to apply some algorithms on it, and then you have to get information out of it. Okay, so one of the technique for getting the grouping the data together is the clustering algorithm. Okay, so basically there are two types of clustering algorithm we have already seen. One is the flat algorithm. Okay, so which works on the kind of uh, all the data set given, and another one is the hierarchical one. Okay, so the hierarchical go on building the algorithm on the given data set. Maybe you have the top down, okay, and then bottom up. Okay, so we will see this particular part later. Okay, now we will talk about the flat clustering algorithm. That is the one of the example of flat clustering algorithm is k-means. Okay, so what does it this particular k-means does? So as the name itself suggests, so there are k different means, okay, of k clusters. Okay, this particular k stands for there are going to be k clusters or k groups to be formed in the data. Okay, and as you have k clusters or k groups to be formed, so ultimately each cluster or each group will have the mean, or it is sometimes also called as centroid of that particular group, or say centers. Okay, so there are k centroids or k centers of that particular group. Okay, so the k is initially given, or it is having some value at the start of the algorithm, and then you actually arrange or group the data accordingly. Okay, so let us see what that particular pseudocode of that algorithm look like. So I'll say algorithm, let's say k-means. Okay, so here you say give what will the possible input is k is the initial value of k clusters. Okay, initial k is means, and then d is the data. Okay, so I say choose let's say k data points, okay, as the initial cluster centroids. Okay, as say initial centroids. Okay, then you will repeat, sorry, repeat, okay, until the stop criteria or some exit condition is not triggered. Okay, so you will repeat for each data point. Let's say for each data point x in dataset D. Okay, do, okay, here in this particular, what you will say, you will compute the distance with the each center. So compute distance of x with each centroid. Okay, and after that, once you have, let's say, if you have three centroids, so you will compute three different distances with that particular of that particular point with three centroids, and now ultimately after computing you will assign x to the closest centroid, okay, or the closest uh, centroid. Okay, so this you will do for all data points. Okay, and then I'll just write here end for, okay, so as to just denote that this is what is the one loop. Okay, then after that what you will do, you'll say recompute. Okay, now once the all assignments are done, okay, you will recompute the centroid using the current cluster assignment. Okay, initially you will have some centroid, then in this loop you will have the new assignments. Okay, and after that you will recompute this. Okay, and this will go on and go on and go on. So this is what is until what, until the condition is until let's say the stop criteria. Okay, or I'll say until the new, until no new assignment is done. Okay, or I will, okay, or there is no change in the centroid, or there is, let's say, if the number of data points are larger, you can have, you can limit to the number of errors, and then you can break out on that. Okay, so until no new assignment is done, or no change in the centroid value. Okay, so these are one and the same. Okay, this is one and the same. So ultimately this is what is your another loop. So I'll just mark this is one loop and this is another. Okay, good. Now here you are computing the distance. Okay, and then there are various distance models. You can use any distance model. So probably how do you calculate the distance? So distance, okay, so I'll just, this is what is the end of this pseudocode. Okay, so distance of, let's say, point xi with the say mean mj is calculated as, okay, it's a vector norm of xi minus mj. Okay, it's a difference between these two vectors, or if you want to calculate mathematically, okay, so it is xi1 minus mj1, okay, square plus xi2 minus mj2, let's say, square, plus, and it goes on up to xi, let's say there are some r features, so xir minus mjr square. Okay, and then under root of this whole summation. Okay, or in short you can write like this, summation of, sorry, under root of summation of, let's say, j, not j, I'll say L is equal to 1 to R, it's XIL minus MJL square. Okay, so this will be like this. Okay, so the number of features that you have, even if you have only one feature, so it is just a difference of that feature and squaring of that and taking the square root of that. Okay, so this is the Euclidean distance model. Okay, and then how do you find the mean of the clusters? So mean of cluster is just a average of these values. So the mean of clusters can be found like this is mj. We have already used this mj is equal to what? Summation of all the x size. Okay, where I is equal to 1 to, let's say, some, or I can say where xi is in uh, cluster j. Okay, are you getting this? Xi is in cluster j, summation of all xi. Okay, right. And then after that, when you sum all the points, then you have to take the average of that. So it will be 1 by size of cluster j. Okay, and that will be nothing but your mean of cluster j. Okay, and like that you will find all the means of this particular clusters. Okay, so this is very straightforward and very easy. Maybe let's start with one example. Okay, so this was asked in somewhere November, December, I think 2018. Okay, so 10 visitors visited the museum. Following are their ages. Okay, so these are the ages: 15, 15, 16, 19, 22, 28, 35, 40, 60, 65. And we want to group them into two different groups according to their ages. And initial values of the clusters are decided as C1 is equal to 16 and C2 is equal to 12. Okay, and solve it using K-means clustering algorithm. And importantly, it is also mentioned that consider the Euclidean distance measure. Okay, so how your approach will be to this particular problem? So I say that let this be data set X. Okay, so you will write all the values of the point. Let's say this is 15, 15, 16, 19, 22, 28, then 35, okay, then 40, and then 60 and 65. Okay, so maybe if you want, you can have the index of this. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10. So there are total 10 points. So like this. Okay. Now you are also given with the initial cluster value. So cluster 1 is having value 16 and cluster 2 is having value 22. Okay, so if you can see, this is 16 and this is 22. So let us say I will write M1 is equal to what? 16, and M2 is equal to what? 22. Okay, so this is for this is the centroid value of cluster 1. This is the centroid value of cluster 2. Okay, now what you will do, you will find the distance of this. Okay, so I'll say distance of X with M1. Okay, and then I will also find distance of X with M2. Okay, so let me draw a line over here. And then, okay, now tell me, how do you find this particular value? So this first value, so distance of 15 with M1 16. So it will be 15 minus 16 whole square and then under root of it. So it will be how much? 15 minus 16 is minus 1 square root. So this will be ultimately under root 1. Okay, and like that it will be for distance of 15 with 22 will be 15 minus 22 whole square and then under root of this. So it will be how much? 15 7, so minus 7 49, so 49 and then under root of it, so it will be around 7. Okay, so it will be this 7, and like that you go on finding out this. So what I will do, sorry, I will do it in Excel. Okay, so let me just give a minute. So that I will save some time in the calculation, and we can have a discussion on that. Okay, so this is your x. What are the values? 15, 15, 16, 19. 15, 15, 16, 19, 22, 28, 35, 22, 28, 35, 40, 60, 40, 60, and 65. Okay. So I hope it is visible to you. Okay. And then distance with x with m1. Okay. And then this is this distance of x with m2. Okay. I write somewhere m1 and m2. M1 is equal to how much? It is 16. Okay. I'll write it like this. M1 and M2. M1 is 16 and M2 is 22. So what you will do? You will write a model here. Okay. So I will write square root of this. Okay. I'll write 15 minus 16 whole bracket square. Okay. So I'll just put as dollar so that. Okay, so I just copied this, and again it will be equal to square root of this minus this raised to 2. Okay, and I'll just write a dollar here so that it will be a relative addressing. Okay, good. Now you got distances over here. So if you can see, these are the distances. Okay. Now what are the cluster assignments? So clusters. So what you will do, you will find the minimum of this. So is equal to, so which one is the minimum one? So I will say this is the minimum one. So it will be 1. Okay. And this will be minimum. So this will be 1. Okay. 0 is minimum. So it will be 1. 3 and 3 you can have it anyone. So I will say take 1. 6 and 0, this 0 is minimum, so it will be 2. 12 and 6, 6 is minimum, it will be 2. 19 and 13, so this is 2. 24 and 18, this will be 2. 44, 38, 2, second cluster, and this will be 49, 43, this will be 2. Got it? So now you have this particular cluster assignment. Okay, so cluster 1 will have these many points. So I'll just let's say highlight with the yellow, and cluster 2 will have, let's say, something else, let's say green. Okay, so this is my cluster 1 point, and these are my cluster 2 point. That's it. Okay, now what was the question? The question was like sorry, following are there. We want to group them into two different groups according to their ages. Initial values of clusters is this and solve it using k-means clustering algorithm. Okay, so this is the step one, right? This is step one. Then what will be the new values of this? Okay, what will be the new values of this? So new values of m1 and m2 will be average of this. Okay, so I will write it over here. It will be nothing but average of how much? This one. Okay, are you getting me? So it will be 16.25, and new values of m2 will be what? Again, average of this. Okay, so it will be 41 point, because as you can see, look at this point: 22, 28, 35, 40, 60, 65. So it will be around 40 to 41. So it will be 41 points. Okay, now what you have to do is, again, I'll just copy this, okay, on this side. Okay, now you have this, okay, and you have new values of m1 and m2. Okay, sorry. Okay, and then again I'll just delete this, and now you have to find out again the distance with this to this. Okay, so again I will write the equation. So it will be square root of 15 minus this, okay, raised to 2. Okay, it will be something like this, and then again I'll just put a dollar over here so that I can drag that equation. Okay, and then this will be this, and then again I will remove the color so that you will not get confused. Okay, and again equal to square root of this minus this raised to 2. Okay, again I will just put a dollar over here so that I can drag this equation. Okay, and then what are the cluster assignments? So clusters, look at that, which one is minimum? This one is minimum, so it will be in 1. This is minimum, 1.25 is minimum, and then this, it will be 1. 0.25 is minimum, then 25, it will be 1. 2.75 is minimum, than this, so it will be in 1. Now look at this, 5.75 is less than 19, so it will be 1. 11.75 is less than 13.6, so it will be 1. And then now look at this, these are the, now 18 is greater than 6, so it will be now 2. 1.6 is less than 23, so it will be 2. 18.3 is less than 43, so it will be 2. And 23 is less than 48, so it will be 2. Now look at this, if you can see what are the cluster are formed. Now this is what is, I'll put it as which one, yellow, and this is what is your green. Okay, now look at this. Initially there were how many points? 4 points. Now it had been changed to 5, because look at this cluster. So from 16 to 16.25 it had been changed. So ultimately this 6 has just missed. Okay, okay, the 22 point I have gone to this. Okay, now again what will be the new values? So it will be average of, okay, the new centroid, average of these. Okay, so it will be this, and then new centroid will be again average of this. Okay, okay, now look at this. Again the cluster have been changed from 16.25 to 17.4 and 41.6 to 45.6. okay, again the same thing. What I will do, I'll just copy this, okay, on this side. Okay, and then m1 is equal to how much? 17.4, sorry, 17.4, and m2, the centroid of second cluster, is 45.6. okay, and then everything, sorry, other than this, I'll delete this. Okay, I will remove the colors. Okay, again the same thing. Okay, this is the third phase. Okay, so if you can see the algorithm, okay, so we are doing For each data point, do this: compute the distance, assign it to the cluster, compute the distance, assign. So we have just now finished 1, 2, and now we are going for the third phase. And this you will do until there is no new assignment or the centroid value doesn't change. It's one and the same thing. Okay. So what I will do now, here I will calculate square root of this minus m1, okay, and then square of this, okay, and again I will put a dollar here so that will be a relative addressing, and then drag it equal to 15, sorry, square root of 15x minus m2, okay, and then square of this, okay, then drag it over here. What happened? Oh, sorry. Now instead of that, you have to do what you have to do. What I have forgotten is to put the dollar. Okay, good. Okay, and then look at the cluster assignment. Sorry, let me save it. Okay. Look at the cluster assignment. Okay, which one is minimum one? 2.4 is minimum, then 3.6. So it is 1, again 1. This is 1. This is 1. This is 1. Okay, and this is 10.6 is greater minimum than 17.6. So it will be 1. Then 17.6 is less than 10.6. So it will be 2. This will be 2. This will be 2, and this will be 2. And as you can see, these are the point in cluster 1. So let me give it as a yellow color, and these are the points in the second cluster. So they are in the grey color. As you can see, again there is one point added into this. So obviously the centroid will get changed. So this is the average of these points. So what is that? 19.16, and again the average of this, it will be something, okay, 50. Again the same thing. What I will do, I'll just copy this on the other side. Okay, this is the fourth phase. Okay, and now let me put m1 is, what is that, 19.167, and m2 is equal to how much? 50. Okay, so as you can see, it had already got changed, but for your understanding, I will again remove the color, remove the data, okay, and I'll write it once again. Okay, is equal to square root of, okay, x minus m1, okay, raised to 2. Then put a dollar. Okay, this is again, this is the distance with the second cluster, so is equal to square root of this, sorry, I'll put one more bracket, this minus 50 raised to 2. Okay, we'll put a dollar over here and then drag it here, and then look at this. 4 is less than 35, it will be 1. 4 is less than 35, 1. 3 is less than 35, 1. 0 is less than 31, so it is 1. 2 is less than 28, 1. 8 is less than 22, still it is 1. Now 15.8 and 15, so this will be 2. 20.8 and 10, so this will be 2. This will be 2. This will be 2. Okay, and now as you can see, these are the cluster assignments. These are the points in first cluster, and these are the points in the second cluster. Okay, now what are the average values? So as you can see, the points have not been changed. So average of this, or the mean of this particular cluster, will be almost same. Look at this, 19.167. Okay, and then average of this 35 to 65 is 50. Okay, and as you can see, this is same as this, and this is same as this. So now after the fourth iteration, okay, so this is first iteration, This is first iteration. This is the second iteration. Okay. This is third iteration and this is fourth iteration. So after the fourth iteration, the algorithm converges, sorry, and then you have the data points in cluster 1 and then cluster 2. Okay. And their final centroid value will be 19.16 and 50. Okay, got it? So you may have understood why I have done it in Excel, because doing all the calculation you need a calculator. So be sure that you carry a scientific calculator when you go for examination. It is allowed in the examination, okay, for this particular machine learning paper. Okay, so again I'll repeat it. So choose k data points as the initial centroids. So we have already given this 16 and 22 as the initial data points. Okay, and then for every data point we compute the distance with the each centroid and assign x to the what? To the closest centroid. Okay, so you will assign x to the closest centroid. Then after this assignment is done over here, what do you do? So if then you recompute what? Recompute the centroid. Okay, this is very important. So this first phase is the assignment phase. So this, you can say, this is assignment phase. Okay, this is your recomputation of centroid. So you can say recompute centroid, and you will do it until the centroid value doesn't get changed. Okay, so since there is no change in the centroid, so we have break from that particular. And look at this. Here you can see that 19.167, and after doing this, it was the output of the third phase, and after the fourth. So you need one extra pass to understand, one extra processing to understand that the centroid is not changed. Okay, sorry. Got it? So as you can see, this had been asked in the examination, and almost it had been asked for 10 marks. And this surely will give you 10 marks. But the only thing is that you have to do it mathematically. Okay, so like here, so under root 1 will be 1, and like this 1, and then you go on. Okay, so you have to do it, you have to solve step by step, step by step, step by step, and then ultimately you will have those values at the end of the fourth phase, fourth step. Okay, so that's it for the first example. Then I will, since here you have only one feature, so the age is given as here as the feature, so you have only one feature, but the things will become little complex when you have two features. Okay, now look at this: P1, P2, P3, P4, P5, P6, P7, and P8. 8 points are given. Okay, so there are 8 points, and each point is having two features, point 1 and point 6. So with two attributes or two features. And what is asked, that apply k-means clustering with initial centroids M1 and M2, where M1 is equal to P1 and M2 is equal to P8. So this is your M1 and this is your M2. Okay, and the clusters are C1, C2, C2 obviously, and which cluster point P6 belongs to. Okay, and what is updated value of M1 and M2. Okay, here it is given that where P6 will belong and what is updated value, or I can say what is the final value of M1 and M2. So it has to be like that. What is the final value of? Okay, so so that you will have at least the breaking condition that M1 and M2 will not change. Okay, so how will you do? So I will write P as the point. Okay, and then distance of P with M1 and distance of P with M2, and then what is the cluster? Okay, C1 or C2. So what is the first point? So let me draw lines over here so that will look nice. Okay, so I will show you initial few points and then ultimately we'll do it in Excel. Okay, because doing that calculation will take much time. Okay, P1, what is P1? 0.1 and 0.6. So This is 0.1 and 0.6. What is P2? P2 is 0.15 and 0.71. Okay. So what you will calculate? You will calculate distance with P with M1. What is your M1? M1 is given as M1 is equal to P1. So it means that M1 is nothing but 0.1 and 0.6, and M2 is nothing but what? M2 is P8. So that is 0.3 and 0.2. Okay. Now, how do you calculate distance of P with M1? So distance of P with M1 will be ultimately 0 because it is the same point. So I will directly write 0. Okay. And distance of P with M2. Okay. So I will calculate this P with M2 is given as under root. Now look at this. 0.1 minus 0.3. Okay. So this will be 0.1 minus 0.3 square plus 0.6 minus 0.2. 0.6 minus 0.2 square. Okay, you solve this and you will get this particular value. And as you go on solving this particular, finding out this equilibrium distance, you will have again the same table, and then you will do the cluster assignment according to the minimum value that particular cluster is having. Okay, so let us start with this in Excel. So I will add the sheet. Let's see. Okay, so this is point P, this is distance of P with M1, this is distance of P with M2, and this is your cluster. And let me add one row. Okay, M1 and M2. Okay, so what is the value of P? Okay, here you will have one more column. Okay, so I will say P is like this. 0.1, 0.6, so 0.1 and 0.6. This is 0.15, 0.71, 0.15, 0.71. Okay, 0.08, 0.08, and 0.9, 0.9, 0.16, 0.16, and 0.85. Okay, then 0.2, 0.3, 0.2, 0.3, then 0.25, 0.25, 0.5, 0.24, 0.24, 0.1, 0.3, 0.3, and 0.2. Okay, so M1 is 0.1 and 0.6, so I'll write 0.1 and 0.6. I write it separately so that I can do it, do the calculation easily. M2 is the last point, so it will be 0.3 and 0.2. Okay, so distance of this with this M1 is equal to, I say, square root of this minus this raised to 2. Okay, plus this minus this raised to 2. Okay, I think yeah. Now again I'll put a dollar over here and a dollar over here so that I can drag it. Okay, and then like that I will just copy this equation. Okay, or I will write it for you. Square root of 0.1 minus 0.3 raised to 2 plus 0.6 minus 0.2 raised to 2. Okay, and then put a dollar over here so that it will be dragged downward. Okay, that's it. Okay, now as you can see, this 0 is less than 0.4, so it will be 1. 0.12 is less than 0.53, it will be 1. 0.30 is less than 0.73. 1.25 is less than 0.66. 1.31 is less than 0.14, it will be 1. 0.18 is less than 0.30, so it will be 1. 0.51 is greater than 0.11, so it will be 2, and this will be 2. Now, as you can see, I'll just make a box, and then this will be your first cluster, let's say yellow, and this will be your second cluster, so it will be green. Okay. Now, as you can see, so this is what is the final cluster assignment. Now, there are only 2 points, obviously, because the M2 is the end point, that is the 8th point. Now, if you can copy this, and I'll post it over here, and then this M1 has to be the average of this. So it will be average of this. Okay. Okay. And this value will be average of your, let's say, y values, whatever, or second feature. Okay. And like that, this will be average of only two values. Okay. This is the first feature, and whatever. And this will be average of only these two. Okay. Let me see what average of. Okay. Now again, since I have changed this, so ultimately I will again remove the color, and let's see. This had been already come, okay, because we have already updated this value, so it had already come. So look at this, 0.07 is less than, okay, I'll delete the cluster assignments. 0.07 is less than 0.48, so it will be 1. 0.06 is less than, so this will be 1. 0.26, 0.77, 1. This is 1. This is 2. This is 1. Okay, because 0.17 is less than 0.35. Look at this, 0.34 is greater than 17, so it will come 2. And then this will be 54, and this will be 2, and this will be 2. Okay, good. Now let me sort this on the cluster assignment so that this will come sort on. Okay, good. Now this is your cluster number 1. So let me make a color of this green, sorry, yellow, and this is your, say, green. Okay. Now again, I'll just copy this and paste it to the next page, and then again, this is, just change this to this. Okay, and this is average of this. Okay, and this is average of this. Okay? And this is average of this. Okay. Now again, I will remove every color and delete this. Okay, already this distance had been calculated because we have just done it nicely in the this Excel sheet. Okay, so look at this. 0.12 is less than 0.42. 1. This is 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 2. This is 2, and this is 2. And ultimately, as you can see, this is going to be the cluster number 1. and this is going to be cluster number 2. Okay, and since these points have not been changed, so ultimately if you calculate the average of this, so it is going to be same, and then you will break to the repeat condition. So this is the third phase or third pass in which your algorithm converges. Okay, sounds good.
Thank you very much for watching this video. If you have liked this video, please click on like button and subscribe to my YouTube channel. And please write your suggestion, queries in the comment box or mail me at dineshjhende@gmail.com. Thank you. Thank you very much.